Welcome to Module 2, Lesson 5. What are rotations and their properties? Please make sure you have your binder, your math notebook, your transparency, and a erasable marker. Now please go to the websites listed here in blue. If you don't want to type these in, I also listed these websites as a direct link on the October 18 calendar page in math that you can go to. Click on each of them separately. Practice moving the slider. Notice what's happening. Okay? Notice what's happening to the objects in the picture. How are the movements different? What are the angle measures in each of the videos? So what you should notice is that in the first one you're watching, the figure is moving counterclockwise, which means to the left. Right? We have a clock here. Counterclockwise means you're moving this way. Clockwise means you're moving like the hands of a clock to the right. So in the first one, the figure is moving counterclockwise to the left. In the second one, the figure is moving clockwise to the right. Let's go look at a graph now with the 4 quadrants and review the angle measures in the 4 quadrants. You know that a right angle is 90 degrees. So if we start on the x-axis and we rotate to the y-axis, we've just created a right angle, which is 90 degrees. Let's rotate again from here, from the y-axis to the x-axis. That's another 90 degrees, or together, it's 180 degrees. Notice we're going in a counterclockwise direction. What if we moved from the x-axis down to the y-axis? Well, we've created another right angle, but let's say we start now where we started from the beginning, and we go all the way around. How many degrees have we traveled now? Well, now we've traveled, you should know, is 270. 90 plus 90 plus 90. Let's say we want to get to where we started, so we do another 90-degree movement. Well, if we started at the beginning and come all the way around to the beginning again, we've gone 360 degrees. And we're moving in a counterclockwise direction. Now let's say we want to move in the other direction. We want to move in a clockwise direction. Well, moving in a clockwise direction, we can still move 90 degrees, except it's not considered 90 degrees anymore. If you're moving from the x-axis to the y-axis down in this direction, you're moving negative 90 degrees. Let's say we'd like to move from continue this clockwise rotation, and we want to move from the y-axis to the x-axis. Well, that's another 90 degrees, negative 90 degrees, or we consider it negative 180 degrees. If we wanted to continue another negative 90 degrees, if we started at the beginning and went in the same direction, it would be negative 270 degrees. And if we wanted to continue from where we started in a clockwise direction, that would be considered rotating negative 360 degrees. Notice when we make the 360 degree rotation, we're making a circle. A circle is 360 degrees. So when you go in a counterclockwise direction to the left, you're rotating positive degrees. When you move in a clockwise direction to the right, you're moving negative degrees. Rotating means we are moving in a circular pattern, and circles have 360 degrees. In the first demo, the rotation is counterclockwise, so the number of degrees rotated is positive. In the second demonstration, the rotation is clockwise, so the number of degrees rotated is negative. Also notice in those 2 demonstrations that the figure is being rotated about point B. Everything is moving based on point B. This is very important. Now look at your classwork. Example 1 on S18. This is showing you a counterclockwise rotation on the left and a clockwise rotation on the right. Now you try this to rotate this angle using your transparency or page protector. Turn off the video while you do this. Now cover the page and draw a segment of P, then rotate about point O to rotate OP to OP prime. Now do exercises 1 through 4 on page S18 and 19. Exercise 1 on page S18 says let there be a rotation of d degrees around center O. Let P be a point other than O. Select a D so that D is greater than or equal to 0. Find P prime, or the rotation of point P, the image of P, using your transparency. So since D has to be greater than 0, we're moving in a counterclockwise direction. So we're moving to the left. So you put your transparency on top of this figure, put a point at O, put a point at P, and now rotate it so that you're moving in a positive direction. Your degree is positive. So I'm going to move point P in a positive direction. You can move it any way you'd like, and I'm going to now connect these 2 points, and this is called P prime. Notice we went in a counterclockwise direction. The next question said, let there be a rotation of d degrees around center O, let P be a point other than O. Select a D so that D is less than 0. Find P prime with a rotation of P, point P using a transparency. So again, we're going to mark O, we're going to mark P, but since we want the angle measured to be less than 0, we're going to move in a clockwise direction. So I'm going to move P. Now I don't have a transparency, so I'm doing the best I can. You do have a transparency. So your rotation should look much better than mine. And we moved in a clockwise direction. So, to answer 3 and 4, which direction did point P rotate when T was greater than 0? You should know that it rotated in a counterclockwise direction. Which direction did point P rotate when D was less than 0? That would be a clockwise direction. At any time, if you're not sure about what we're doing here, you need to pause the video and go back and rewind. This is a little discussion now, and something I just want you to be aware of. We have a circle on the smartboard, and we have a point O here connected to here. We'll call that point P. Well, let's say we'd like to rotate P, and we want P to wind up maybe here. So we want to have that P prime. So I'm going to draw a line connected to P. Well, let's say we'd like to rotate about point O again. This time, let's say P should be rotated here. Instead of P prime, it's P double prime, and let's draw that. We'd like to rotate P again, and let's say we'd like to try rotating it over here. So this is P triple prime. Let's say we keep rotating P. So we're going to rotate it here, and here, you should eventually see that this starts to look like the spokes of a wheel. That the points, when they're rotating, are on the circumference of the circle. So each segment is turning out to be what? It's turning out to be the radius of the circle. Now that we know how to rotate a point, let's rotate an image. So go back and look at those two demonstrations again of the counterclockwise and the clockwise rotations. Pause the video while you do that. Notice that what's being rotated is a line segment, a point on the line, and a point that's off the line. So it's a few things that are being rotated. And notice what happens to them when they rotate. You should know that the images you rotate are not always connected to the point you are rotating about. So that one point off the line is not in any way connected with point P, with the point that you're rotating about. It's not any. It's being rotated around the point of rotation, but it's not in any way connected to the point of rotation. This is the case with exercise 5 and 6 on pages S20 and S21. Do these problems now using your transparency. So turn off pause the video while you do that. Okay, question 5 says, let L be a line, AB be a ray, CD be a segment, and angle EFG be an angle, as shown. Let there be a rotation of D degrees, so you pick the degrees, around point O. Find the images of all figure when D is greater than 0 or equal to 0. So D could be 90, D could be 45, D could be 10, D could be 50, D could be 180, as long as it's greater than 0. So you should be aware that when the angle that you're rotating is a number greater than 0, you're rotating in a counterclockwise direction. So you're moving in this direction, counterclockwise. Okay? So I'm going to draw some figures on here. I don't have a transparency on here, but you should have had a transparency on here, on your page. You should have, since the rotation is around point O, you want to make sure that you put a dot on O and then trace the other figures. You want to trace DC. You want to trace angle EFG. And you want to trace ray AB. And then you want to put your pencil points or something on O. And also line L. We're rotating line L too. So put your mark up the rotation point O, mark up the fourth, the line, the angle, the line segment, and the ray, and then rotate in a counterclockwise direction, all of these figures. So they need to all be drawn in the transparency first before you rotate any of them. You want to rotate them at the same time so you know you're rotating everything the same number of degrees. And then turn everything. Rotate it counterclockwise to the left. So everything should move. So this is going to move in this direction, except this is going to turn it. Unfortunately, I can turn it a little bit, but I don't know if it's exactly going to be the same. This is going to turn. In the same manner. Okay? This angle here is going to turn and move. Okay? And they're all going to move the exact same way. So they all should be, mine are not correct because I cannot put a transparency on the smartboard and then move it. But you can use your transparency and everything should rotate cleanly, all at the same Distance, all at the same angle measure. Number 6 says, let AB be a segment of length 4 units and angle CD be an angle of size 45 degrees. Let there be a rotation by D degrees where D is less than 0. About O. Find the images of the given figures and answer the questions that follow. So you want to make sure for this that you are rotating in a clockwise direction because the angle measured D, the degrees, are less than 0. So you're going to the right. So you're going to draw a segment. We'll call it AB as it says to. You need an angle CDE. Yours can be anywhere you'd like. I'm just putting them here just because and this is going to be 45 degrees as it says in the instructions. And then you're going to rotate those two things about this point O. O is right here. So you're going to put your transparency on your drawings of your line, segment, and angle. Put a point at O on your transparency. Once everything's on your transparency, you're actually going to turn your transparency in a clockwise direction. So you're turning your transparency to the right, and then mark where your object's moved. So I'm going to pretend I have a transparency here, and then if I'm going to move it, it should move in this direction. But I do not know how far I'm really moving it because I'm not using a transparency. So you get the idea though, I hope. Your transparency is the best thing you can use to figure this out. If you're not sure about this, go back, pause the video, and try it again. You should start to see after doing these problems that rotations have properties similar to translations and reflection. A rotation maps a line to a line, a ray to a ray, an angle to an angle, just like reflections and translations. Rotations preserve lengths of line segments and degrees of angle measures. Same thing as translations and reflections. Also like translations and reflections, if there are two parallel lines, the image of the lines will remain parallel with any rotation. By the way, if you're copying these notes, as you should be pausing the video to copy the notes before continuing. So, translations are like reflections in that rotations are like translations and reflections, where if you have two parallel lines, the image of the lines will remain parallel with any rotation. So if I rotate these two, they're parallel right now, they rotate together. They rotate in tandem. Okay? There is something unique. If there's only one line and it is rotated, the image will only be parallel to the pre-image if the rotation is 180 degrees. You'll see this in exercise 7 and 8. So you can do those now in your binder. Let me just demonstrate. Here's one parallel line. If I decide to rotate this, let me copy this image. Actually, no, I will copy the image by drawing over it, and then I will turn the red image. But you see, it's not parallel. But if I turn it 180 degrees, it is parallel. Okay, so try exercise 7 and 8 now, and let's pause the video. So question 7 says that L1 and L2 be parallel lines. Let there be a rotation by D degrees, where the degree measure is less than negative 360 degrees, is greater than negative 360 degrees, but less than 360 degrees. So in other words, you want to do a rotation that isn't more than one circle of a rotation. Okay, you want to go a little bit of a turn or a lot of a turn, but not more than one circle of a turn. You don't want to go past 360 degrees. About center O. O is right here. Okay? Are those images, after you've rotated the two lines parallel? You should find out that they are in fact parallel. So I will draw, I'm going to draw two parallel lines, but I have to connect them somehow in order to move them at the same time. So this red line here, you can ignore. It's the only way, it's the thing I need to do to rotate these. So now let's turn these about center O. Are those red lines, even though they're rotating, are they still parallel? Yes, they are. Okay, question 8 says, let L be a line and O be the center of rotation. Let there be a rotation by D degrees where D does not equal 180 degrees about O. Are the lines L and L prime parallel? So here's O. Let's draw a line about this line, and I'm going to now, this is like a transparency, and I'm now going to turn this, but I'm not going to turn it 180 degrees. I can rotate it counterclockwise. It's not 180. I'm doing 90. Are they parallel? Is the image parallel to the pre-image? No. What if I keep going? Still not parallel. What if I go in the opposite direction? Not 180 degrees. It's still not parallel. So that should show you that when you rotate just one line, its image and its pre-image will not be parallel unless you rotate 180 degrees. Now read the lesson summary on page S23. Pause the video if you need to. The summary is important. I'm not going to repeat it here. Be prepared with questions on Monday regarding this lesson. We will work on the exit ticket and problem set for this lesson on Monday. This concludes lesson 5. You can email me if you have any problems, and I can try to address them over the weekend. But there is no reason why this video shouldn't load for all of you. Okay, try different browsers. It should work.